So, ladies and gentlemen, now we would like to introduce our next special guest, Dr. Stefan Wolfram, founder and CEO of Wolfram Research, creator of Mathematica, Wolfram Alpha, and the Wolfram language authors of the new kinds of science and other book, originators of the Wolfram physics project. And his topic is the future of computation and its opportunities for student and teacher. So I would like to remind that you have 30 minutes for your presentations. Thank you.
Okay, great. Well, nice to be with you guys. This is one of the advantages of a pandemic, that I can join you even though I'm halfway around the world. I visited Cambodia a few years ago, and we've had the pleasure of collaborating with people there since on a variety of things to do with computational education. I think David Vannanen talked about some of them yesterday. I should explain, I'm a tech CEO and a scientist. I do a fair amount of educational work and even some mentoring of CEOs and kids, very different communities. But the thing I want to talk to you about today is a mixture of some things that are quite intellectual and some things that are very practical. I think the first thing to say, I want to talk about computation. And the idea of computation is something that is very important. It's kind of going to be the future of pretty much every field. It's kind of one of the few really new intellectual paradigms that's emerged, and certainly in the last century. It's something where in the time since education became a widespread thing in many countries, it is sort of the first really major new idea. And that represents both a challenge and an opportunity. It's a challenge because people don't know how you teach this idea of computation, how you teach kind of the computational method of thinking about things. On the other hand, it's an opportunity because it means that countries and people who have been long developing various educational methodologies, they don't have anything special to contribute in this area. It's something where there's sort of a very level playing field around the world. So I myself have been involved in developing this kind of computational paradigm for about the last 40 years, and in particular developing a big stack of technology whose purpose is basically to automate the process of doing computation to the point where it's accessible to as broad a range of people as possible. And it's been a very satisfying thing because we produce software that's used by pretty much all major universities. There's site licenses for it for basically all major universities in the US and many other countries. We also provide the software that's used by research and development organizations around the world. We also supply the computational knowledge for things like Apple's Siri and Amazon's Alexa and other things. So we built this technology stack that's used by sort of the world's leading organizations for research and development and kind of high-end education. But what we've tried to do is to automate this to the point where the technology we have is accessible not just to these folks, but to anybody, and in particular to kids, and to make it so that it's possible for basically any sufficiently motivated kid, aged probably 11, 12 up, to get access to computational knowle and to be able to start using computational methods. So I thought I would just demonstrate a few things here, and then we can talk a little bit about kind of the general questions here. So this is just a desktop version of our Wolfram language, our computational language, which is sort of the language for having humans communicate with machines. It's the language that's used by, as I say, lots of universities, research and development organizations, and so on. And there's also a version of this for the cloud. You can just go and freely get this in various environments in the cloud. Okay, so what does it do? Okay, so you type in 2 + 2. People understand how to do that. Then, if I was showing this to kids, the next thing I'd probably show them is, okay, I can type in something like this. I can say range of 10. That says make a range of numbers from 1 to 10. Maybe I can say range of 100. Okay, computer does that too. Range of 1,000, computer does that too. Let's go back to range of 100. Now we could say, let's ask the computer to take that and make a plot of those results. So this is kind of, we're telling the computer what to do, and this is all quite straightforward. Now, for example, maybe we could say, let's just get, what can we do here? We could get a list of words, for example. Oops. We can get a list of words. So by default, it'll be in English. Okay, so there's a list of 40,000 words in English. So it's kind of fun. You could pick a random word if you want to, and you could say, let me get 10 random words, and then I could see how many of these do I know. I can guess how many words I know in English. But I could take this word list here, and for example, I could just say take the first letter of every word here. So now I'm going to get a list of first letters. I could say, let's find out what's the most common first letter in English. Okay, let's say we find a word cloud of all of those, and it'll tell us, okay, looks like S is the most common first letter in English. Maybe you could try a different language. I don't know. What would you like to try? Let's try, how about French there? So it'll probably have to load in, okay, there it goes, showing us the corresponding result for French. So one of the things that's important here is our goal is to have everybody be able to kind of access the computational intelligence that has been accumulated kind of in our civilization. What we've spent the last 35 years doing is kind of building all of that computational intelligence into our language so that everybody can have access to it. And that computational intelligence can be about all kinds of things. Let's say, I don't know, I could type oops, I need to, keeps on saying, let somebody into the room, and it captures my mouse. So I'm just going to, I'm going to hope somebody else is going to do that. And let's see if I can continue typing here and not have it capture my mouse. So let's say, I'm going to just use English here to say, give me a picture of an owl. And the important thing is, I'm using English language, but that's being turned into computational language. Now I get a picture of an owl, and now I can say, let me take that picture of an owl, and let me say, I don't know, let's say, detect the edges in that picture of an owl. And so now I'll be taking this picture and doing something with it. Maybe I could take, let's take another kind of picture. Let's say we want to get, we can start asking questions about all kinds of things. Let's say, okay, what's important here is that our computational language represents things in the world. So it's something where kids, for example, can immediately, if they're interested in some particular area, they can immediately start exploring that computationally. So for example, here I might say, this is Van Gogh, a painter. Let's say notable artworks of Van Gogh. I'll get a big list of those. Let's say, I don't know, let's pick the first 5 of these. And then let's see if we can get pictures of them. So here, let's get some pictures. And then perhaps I could say, given one of these pictures, I could say, okay, what colors did Van Gogh use in that picture? Or for example, here I could say, and I could say, show me a picture of kind of where the colors in that image lie in sort of color space. So there we're seeing it's a lot of blue and yellow and so on. So the thing that's perhaps important here is this kind of an opportunity to see that everything in the world can kind of be thought of computationally, whether one's talking about paintings, whether one's talking about words, different kinds of things. So let's pick another example. Let's say a country. Let's take Cambodia, for instance. Okay, so let's say, let's ask about the population of Cambodia. Oops. Okay, so it says that, and maybe we could say, what's been the population over time, for example. Actually, let's pick a different example here. Let's say, we could look at that. We could say, for example, let's look at countries in Southeast Asia. And hopefully we'll get, okay, now let's say, for example, let's ask for flag images. So here we'll get images of flags in Southeast Asia. Perhaps we can do something where we say, let's arrange those flags. Let's see what an artificial intelligence system would do to arrange those flags in, let's see how it would group those flags. So it's showing us that these yellow flags are down in this corner and so on. Or for example, let's pick Cambodia as an example here. Let us say, let's ask, for example, for, let's say, let's do this. Let's say, what are the nearest mountains to, let's say, the center of Cambodia there? And let's say we want, let's say the 10 nearest mountains to the center of Cambodia. So this is, again, we're going to be asking for something that involves knowledge about the world, but now we can go and say something like, let's make a geographic plot of where those mountains are. So we should get a picture of that. Okay, there we go. And perhaps we could say for one of these mountains, I don't know any of these, but hopefully some of you do. We could say something like, let's take that mountain and let's say show us the geo elevation for a disk that's, let's say, 5 kilometers around that mountain. And then let's say, let's see whether we can do this. We can try and make a picture of the surroundings of that mountain. Okay, so there's a picture. So, you know, what are we doing here? We're taking all these different kinds of things in the world and we're kind of thinking about them computationally. And we're kind of giving people a language in which they can talk about these kinds of things in computational terms. And what kind of a thing is going on here? We're kind of teaching this computational method for thinking about the world. It's not the same as teaching computer science. It's not the same as teaching coding. Those are things where the low-level computer languages that exist, whether it's Java or Python or whatever else, they are essentially dealing with showing people how to get the computer in its terms to do certain operations. What we're trying to do with our Wolfram language is to provide a way to let people think in the terms that they want to think in and communicate to the computer in this computational language that both the humans understand and the computer understands, and a language in which it already has knowledge about things in the world. So you're able to talk about things in the world directly. You're not just dealing with the low-level operations of the computer. Now, one reason that's important is this idea of computational language, the idea of using computation to explore things. This is a very general idea. It applies whether you're doing, you know, architecture or archaeology or aeronautics or zoology or anything else. It's something completely general across all these areas and something that's directly applicable to these areas. It's very different from computer science, which is kind of a low-level operation that's relevant if you're kind of the engineer who's looking sort of under the hood of the machine to see what's going on inside. And something that has happened in kind of computer science education around the world is this kind of notion that people should be taught kind of how to write code in low-level languages. I don't think this is terribly useful, and in fact, it's useful for some small section of the population, but in fact, people like me have spent huge amounts of effort essentially automating all those low-level operations. But what's left over for people is to take what they're thinking and present it computationally, use high-level computational language to be able to actually achieve things in different areas using a computer. And essentially the way I see it is, it's what we have in this computational language is sort of an extension of our ordinary human natural language. We get to express ourselves not just by using ordinary words in English or Khmer or whatever else, but also by using these words in this computational language. And by the way, one of the things that I think is very powerful from an educational point of view is these notebooks that I'm using here you can kind of mix kind of natural language text with this kind of computational language. And so this is a way of having students express themselves in this mixture where both they're writing some text and they're also writing computational language, and they're having the computer help them to express their ideas. And this seems to be a very powerful approach to both students describing what they're learning and also teachers communicating communicating ideas. So but I was going to say that in kind of computational language is kind of we have ordinary text. We teach people mathematics. We teach them essentially mathematical language. Computational language is kind of the next stage from that. Mathematical language, the kind of the notation of mathematics was invented about 400 years ago. It was sort of a major thing in the history of thought, and it led to the development of algebra and calculus and so on. It led to the mathematical sciences. Now our goal is to have a computational language that can take advantage not just of the ideas of mathematics, but the much more general ideas of computation. And the great thing about computational ideas is we get to have computers help us explore those. The other thing is, with computational language, we get to kind of define the notation for thinking about all kinds of things computationally. All these different fields, this kind of notion of computational X for all fields X is a really powerful one that we're seeing take over for many, many different kinds of fields. For sort of any field X, there either is now a computational X or there will be, and it will typically be the future of that field. So what does it take to get kids to be fluent in computational language and to be able to really think in terms of computational language? I don't know in total precision. I'm not the one who's been sort of totally at the front lines of this. I will say that, for example, I wrote a book a number of years ago that was actually intended primarily for kids. It's available online. You can just find it free online and so on. But it's turned out to also be a book that's used by lots of adults and so on. But this is a book that kind of goes through without using math or anything like that. I think this book is suitable for kind of probably age 11 or 12 up. I think my observation is it takes students maybe 20, 30 hours of kind of study to get to the point where they're reasonably fluent in computational language. And the thing that gets really exciting is when students can go from, can kind of take an idea that they have and start spontaneously exploring it computationally. So we have a number of programs where we've been working on this. We have a high school summer camp that we've been doing for many years now. And these are what happens at that summer camp is students do projects. They have 2 weeks to do them. And these are some projects from this year. And you'll see all kinds of elaborate sorts of things about simulating satellite collisions and simulating relativistic objects, all sorts of things like this. Now, these students, the ones we end up having, are mostly fairly well-prepared students. We would very much like to extend this much more broadly to students where their initial preparation is not so great. But this gives a sense of what a high school student is capable of doing with this computational language in a couple of weeks. So I will say that as I mentioned, kind of what we have here is available in both on the desktop. It's available in the Raspberry Pi computer. It comes free with the Raspberry Pi computer. It's also available, as I said, on the desktop here, and you can get to it. There is a version. Where did I have this here? Where did I have it? There we go. Programming Lab is kind of our version that's intended for students to sort of immediately and on their own, not necessarily with a teacher, be able to start exploring computational language. Okay, well, I think that one of the things that's interesting and sort of highlighted by our summer camp is in this world of computational language, students can start doing research. They can have ideas, they can start exploring things because there's this new tool that hasn't been available to people until very recently. It's been available, well, for 30 years altogether, but it's progressively been expanded, and it's a lot of the things I'm showing you are fairly recent pieces of technology. This is something where there's sort of a frontier that students are able to get to very quickly. Well, I think the thing that's interesting, I suppose, is students who kind of learn to do this fluently, they sort of have an immediate job, because data science, for example, which is what you can do with this kind of computational language, is something which is needed in all kinds of areas, and any student anywhere in the world can basically expect to find something that, if they're fluent in computational language, they can be doing data science for anybody. And I think that's a really interesting thing, and something that for me is interesting. Our company is based in the US, but we have operations in many places around the world. And one of the things that is always interesting to me is to see in which places we get development of kind of the relevant sort of knowledge of computational language. We have two quite large operations, one in Peru, one in Armenia. I'm hoping one day we'll have one in Cambodia. I think I should say, I might mention, as I say, I'm not, I'm just a tech CEO. It turns out that my brother, who's based in England, has actually been working much more extensively than I on a kind of a way to really think about how one uses computation in the educational process. And he's really focused on starting with math education and trying to understand what's involved in doing math education in a world where we now have computers. And so he's developed and worked with a bunch of different countries and other organizations on kind of deploying sort of an approach to math education that's informed by the existence of computers. I see I'm running out of time, and I'd really like to have time for questions and discussion. So let me just say that the sort of the big opportunity here is take computational language and be able to deliver it to kids in all sorts of situations. I'd like to say I'd really like to see some kids from Cambodia come to our summer camp, and I'm going to say here that we're happy to support, if we can find 2 adequately prepared students from Cambodia, we're happy to support them at our next year's summer camp. I also, it's been very interesting to me over the years. I said I do a certain amount of mentoring of 2 communities of people, CEOs and kids. And it's been particularly interesting to me to see kids from pretty low-level backgrounds. Sometimes I've even done direct mentoring myself of them, be able to kind of jump to the front of the line, having mastered kind of computational language, jump to the front of the line and be able to do valuable things in the world, even though one might not expect that from their backgrounds. So anyway, that was, I wanted to kind of give a little bit of an introduction to this sort of notion of what's possible with computation in the world today and what some of the educational opportunities around that are. So I am happy to try and take questions if people have them.
So thank you so much for your wonderful presentations, and I'm sorry that I announced your times wrongly, because you have 45 minutes, but actually I announced only 30 minutes, so I apologize for that.
I could go on. Let's have a discussion. Good.
I'm sorry. Anyway, we still have a lot of time for question and answer, because there are many questions, yes, in the chat box now. So, yeah.
Should I just look at the chat to find the questions, or would you like to?
I would like to ask the questions for you, so it is easier for you too. Yeah. So, yeah. The question is that, is the information from Mr. Chanachin, is the information from Wolfram software more reliability than Google? How is better or easier than Google? What is the significance of this software for social science that you suggest us to use?
Okay, well, let's see. Let's take several of those things. Well, so Google is trying to do something very different from what we're trying to do. Google is taking web pages and giving you information about what web page you should look at. That's completely different from what we're trying to do. What we're doing is we are computing answers. We're doing computations. Now, the thing that's probably closest to something that you might see in a search engine is our Wolfram Alpha system. This is Wolfram Alpha. We can say something like, what is the population of Cambodia? This is what powers computational knowledge in Siri and Alexa and so on. And there's the results, and there's a plot of against time, and there's some information. Look at that. You have lots of young people in your country. What are we doing here? This is data, knowledge that we've accumulated over the last 30 years or so from all sorts of sources around the world. And what we do, we are responsible for this knowledge. We're curating this knowledge from sources that are kind of the primary sources in the world. That's very different from what a search engine is doing, where it's just go find a web page that somebody's put on the web. That's the first thing. The second thing is that we're actually able to compute things. So if I say, what's the population of Cambodia divided by Thailand, it's going to be able to do that computation, work out the result. That's not something, there's probably no page on the web that has that information. This is at the sort of simplest level. At the next level, when we're dealing with Wolfram language, we're really dealing with something completely different. We're dealing with something where we are creating a language that allows us to express things computationally. So, and the thing that's happened here is when we have that language, it is the requirement to have sort of accurate computational knowledge is very high. Because if I want to know about these mountains in Cambodia, I better have all the mountains, or this is going to be a meaningless computation. So that's sort of a much higher level of effort required to sort of make that computational knowledge appropriate. Now, let's see. You're asking also about social science. Well, let's see. What can we look at with social science? What's a good thing to look at in social science? We have tons of data about social science kinds of things. Let me see. Let me pick an area here. Let me see what's there to look at. Social statistics. How about that? What do we have here? Could have healthcare statistics. We could have something about let's see, unemployment rate, female unemployment rate in all countries. What's the ranking of that, and so on in different places. Or we could go, we can actually, so this is in Wolfram Alpha, where we're just asking kind of simple textual questions. In Wolfram language, we can go, let's see, what can we do in social science? We could look at, let's look at the kinds of things that Wolfram language knows about. Let's say social, cultural, and linguistic data. Okay, so let's say, for example, what would you like? Socioeconomic data? Okay, we can start there. Okay, for example, we might have information about universities. We can go compute things about universities. Or let's take an example. Let's try taking, I don't know, let's take, we could take a university like Harvard University. We could compute things about it. Or let's do something different and a little bit bizarre. Let's take a geo image of a disk, let's say a range of, I guess this isn't really social science, but it's something fun at least. Let's say we find an image of 1 kilometer around Harvard University, and that should give us this wakes up, there we go. So there's a satellite image, and now we could take that satellite image and start doing processing on it. We could find roads in it. Let's just say let's do the thing I was doing earlier of edge detection. Let's take that. Oh, that made a big mess. So we have to actually do a little bit of computational thinking here to figure out how would we pick out the road here, rather than just having this whole mess with all the houses. How do we actually pick out the road? But that's at least the beginning. I mean, there's tons of stuff one can do in. I mean, let me give you one more example. Not really social science, but it might be fun. Let me say, let me audio capture here. Let me say. Hello, I am giving this talk right now. Okay, so that will record the sound, record what I said. I can make a spectrogram of that. And this will show the, that'll show kind of my voice. It's showing frequency as a function of time. You can kind of pick out the words here. Probably we could actually tell it to, so we could say speech recognize that piece of speech. Again, it's kind of interesting. You could take a bunch of kids in a particular class. You can have them all say a particular thing. You can then compare the way that the different ways they say it. Okay, so it did a reasonable job there in translating the sound. Let me look at the sound. I could just make an audio plot of 929. That this will be just a plot of the sound as a function of sound intensity as a function of time. It did a reasonable job converting that to words. So there's a few indications at least. Another question. I saw there were really
thank you so much for your answer. Yep. So another question is from Mr. Koile. So yeah, dear Professor Stefan Wolfram. So Wolfram Alpha is so interesting. Is it free application that everyone can use it for free as Google? And does it have tons of pictures like Google that we can download and use whatever we want? And is it be able to apply for all subject matter?
Okay, so yes, it's free. There is a let's see. Let me share again. So yes, it's free. There's a version of it. The pro version allows you to do a little bit more. So if I say, let's say I ask to do a piece of calculus, I don't know, integrate x sine x. The free version will show you the answer. I think to get the full step-by-step version is the pro version. In terms of picture, in terms of what it does, many different areas. I don't know, let's pick an area, it depends what you're interested in. Let's pick chemistry, for instance. We could ask for, I don't know, let's say methanol or something. Now, if we take that, it'll compute a result there. It's computed a picture. You can absolutely take that picture and use it wherever you want. You could just paste it into whatever you want to paste it into. So it and I mean but these are generated pictures. So these are pictures. I mean, if we ask it a picture of a oh, I don't know, what could we ask it? Let's say let's try asking it. I have no idea whether this work because I don't know whether there is one, but let's just try. Let's ask it what the national flower of Cambodia, seems to be this kind of plant. Let's see what this looks like, see whether we can get a picture. I don't know whether they'll have a picture of it. No, it doesn't have a picture of that particular plant. It shows us where that plant is in the tree of life, but it doesn't happen to have a picture of that particular plant. But again, so anything that you find on Wolfram Alpha, you can absolutely use in that way. And you can compute, let's say that you have some, I don't know, mathematical function. Let's say we have something like, I don't know, x squared plus y log x sine y or something. That mathematical function, it will now generate, probably, I would think it will generate, we just typed in that function. We didn't specifically ask it something. We didn't specifically say, make a plot. Oh, that was rather boring. That function is rather boring. But I could take that that plot and use it and so on. But I think so Wolfram Alpha is something where you're just typing in one line of text. Wolfram Language, you're going and actually creating computational language and building up sort of arbitrary calculations, arbitrary, sort of taking arbitrary things you're thinking about. There's kind of an intermediate version of these things, which is the Wolfram Alpha Notebook Edition, which is actually a new system just available now. This is a product that is becoming rather popular in the US. We just released it very recently. Let's see, I can make it larger here. This is something where this is sort of a mixed thing between, so let's say I say x log x here. It'll now use this, it'll now treat this as a piece of linguistic input, and it'll say something like this, and I could say there's the result, and let's say I find the integral of that. Now it'll do that computation. So this is something where you can use natural language to build up this notebook, to build up this kind of a sequence of steps computation. Another question, perhaps.
Thank you so much. So we have many questions. So the other question is from Mr. Mutkel. So thank you so much for your interesting presentation. My question is, most software developed for calculation like the statistic software, what kinds of software or apps should be developed solving problems like problems exercise, especially to deal with random process or uncertainty problem like dynamic software or apps to solve all type of problem, not just static calculation?
Okay, I think I understand. I'm not sure I understand that, but let's try. Okay, so if you're interested in dynamic kinds of things, one of the things you can do in Wolfram language is just say make a manipulate. So let's say we say manipulate a plot of sine AX. X goes from 0 to 10, A goes from 1 to 5. So now we can make something here, and this is now an interactive plot. Okay, we could do the same thing in 3 dimensions and so on. Now, one thing you guys might find useful is there's also a, let me pull this up. Hold on a second. It's not relevant, but let me go and use that tab here. Let me show you a website. Oh my gosh, no, I should be able to type here. Demonstrations.wolfram.com. So this is demonstrations.wolfram.com. This is about, how many is it nowadays? It's about 12,000 demonstrations of all kinds of different things. So these are interactive demonstrations. So we can take one of these demonstrations here, and we can either run it directly on the web, or we can say copy it, and let's say we can copy it here into our notebook. And now this is now an interactive object that I can do computations with. This is a fairly complicated one here. Okay, so this is how you can use Wolfram language to create dynamic computation, demonstrations. And as I say, this demonstrations project, this is a free site with 12,000 interactive demonstrations that you can either use directly on the web here, or you can, let's just take this one. I don't know what this is doing here. Let's see. It says initializing live version, so we can see whether it will come up on the web, or I can, there we go. Now let me maximize it here on the web, and now I can just move that slider, I hope. Let's see. Not doing exactly what I expected, but I think you should be able to just move that slider here on the web, or I could take this and I could copy it in here. I could also copy it into the cloud version of Wolfram language, and I can go and run it here. Okay, so I hope was that responding to your question? I hope so.
Thank you so much for answer. So we got another question from Mr. Originator. So the question is, what are the most challenging factors you have faced in organizing Wolfram Cloud, and how could you do to overcome them? Gosh,
I mean, the project to build Wolfram language is one that I started 40 years ago. The actual Wolfram language as it exists today, we started building 33 years ago now. the thing which I'm sort of proud of is that this whole language that we've built with all of these different capabilities is a very coherent thing. Everything, all these different pieces that we built all fit together. And that's something that has taken huge amounts of effort to ensure that. Actually, one thing that is kind of interesting in modern times is that we have been, the internal design meetings that we have that in which we're actually figuring out how to do these things. We are live streaming many of them. So we've live streamed 500 hours or so of these internal meetings showing what it takes to kind of figure out the design of our language. But in terms of I would say that the biggest, so technically, the biggest challenge is sort of maintaining coherence of this language over a long period of time. In terms of actual software engineering, this is a very big software system, one of the biggest ones that's been built in the world. The actual moving it to the cloud is also a very complicated thing, because this whole user interface that we built that works on desktop computers, replicating that in the cloud is a difficult thing. I would say that in terms of the world at large, the most challenging thing is that we've invented a lot of things that are still many, many years ahead of where most people have reached in terms of thinking about what computers are able to do. I mean, I often talk about the things that we're building as being artifacts from the future. And some of the things that we've invented, that we invented 30 years ago, people are only just now beginning to understand what these things are. And there are many things where I think, sort of left to their own devices, it could be 50 years before people know these things. One thing that I happen to have done, I'm not only a creator of software, I'm also a user of it. And so one of the things that has been a big thing this year is the fact that we've managed to use kind of these ideas about computation to solve a very major problem in fundamental science of finding a framework for finding fundamental theory of physics, which is something people have been interested in for a long time. We've kind of, 100 years ago, people made a lot of progress on that. There's been some incremental progress since that time. We've kind of been able to really take a major step forward. But the thing that I realize about this fundamental theory of physics is if we had not done this now, it will be at least 50 years before anybody got around to doing it. And that's something to realize about the software technology we're building, is a lot of it is very far ahead of what people kind of are expecting right now. And that creates both a challenge for us and an opportunity for everybody, because it means once you understand this, you're basically pulling in an artifact from the future and you're able to make use of it today. And that's something that's certainly, as a user of our technology, that's something that's very exciting to me. It's something very exciting for me to see other people be able to do that in many different fields. And so that's kind of a, oh, did I not share my screen? I didn't share my screen. Well, doesn't matter. I was going to, that was the thing I was showing, but I didn't share that. And anyway, so that I would say that's kind of the challenge there. Any other questions?
So thank you so much for the question, for the answer. So we have another question. It's about, do you think in the future technology are enough to make human mentoring and coaching become less necessary? And will technology of computational language make students give too much independence, which ultimately result in the reductions in interaction between teacher and students?
Right. Well, I think one of the things, computational language gives students a kind of superpower. A person with their computer helping them can do amazing things. Now, it's still important to have a teacher helping the human do the human side of what has to be done. And I think that, in a sense, what is happening is a student with computational language is able to do amazing things, including things that their teacher, they can take their ideas and with the help of a computer develop them in ways that the teacher won't necessarily know. I mean, I do a certain amount of work with actual kids And it's always amazing that they will discover things, just typing on their computer, they'll discover all kinds of things. It's like, why is this true? I don't know. That's I have to think about it. It's not something that the kid plus the computer is easily able to sort of figure out more than I can figure out. Now, in terms of does it, how does that, will we be able to have kind of something where interactions with students happen all through a computer? I don't think so. I think particularly in the K through 12 teaching sector, I think that the human interaction is really pretty important. It's pretty important in motivation. It's pretty important in that sort of the human interaction is really, really a critical thing. However, I think that the way that interaction works and the extent to which the students are able to sort of do work by themselves and do things that and have the teacher be somebody who's learning with the student, so to speak. That's something that can happen increasingly as we make more use of computational language and as students make more use of computational language. I mean, I think the thing that students pick up on this computational language pretty quickly, and it's like student plus computer is can really zoom forward, and teacher becomes more of a facilitator of that and a motivator of that than somebody who's so much just communicating, here are some facts, learn these facts, so to speak.
Thank you so much for your wonderful answer. So, because your time is over, but however, the next section is break time. So, would you mind answer some remaining question?
I'm happy to, yes, please.
So, thank you so much for your kindness. So, the next question is from Chain Vijaga. So, dear doctor, for those who have no ICT background or less knowledge about ICT, to you, how to support them learn Wolfram language before they are able to get things what they want in the computational setting?
Right. It's an interesting thing. If you look at teachers who are using Wolfram language, you might think they are computer science teachers and math teachers. And certainly those kinds of teachers use our language. But we also find that a lot of other kinds of teachers really pick this up well. For example, there's a person who's actually, I think of two English teachers who are really spectacularly impressive in terms of what they've done with Wolfram language. Also true with teachers of various other kinds of sciences and so on. But the thing that's really interesting is this is not something where, if you've learnt if you've kind of learnt IT and so on, you have a big advantage. This is a new kind of thing. It's a new sort of intellectual direction. And it's something where people who just have kind of a systematic way of thinking independent of their background can get a long way. And by the way, for example, the two English teachers I'm thinking of, they have done all kinds of things with their students that I'm aware of, like, taking a text of a Shakespeare play and figuring out, what's the social network of the characters based on that, or the other one was, I know, doing a bunch of stuff with poetry and so on. And these are things that the math teacher won't know to do that. The math teacher won't know about poetry or Shakespeare plays and so on. But these people who are teachers of, for example, English, they, like kids, can get into this computational language and make use of it. Now, if you're a math teacher, you can also do spectacular things with this, but you don't need to be a math teacher or a computer science teacher to be able to get into this kind of thing. And I would recommend, for example, that book that I wrote and the various courses that come along with it is a good way for teachers as well as students to get into computational language.
Thank you so much. So the other question is, can we apply math type in Wolfram? If can, how?
Apply what, sorry?
Math type, mathematics. Math type. I'm sorry, math type. Math type means like the keyboards that floats on the screen so that we can type in for better typing in like Word or Excel, because actually in the Word or Excel, it doesn't appear with the better keyboards for typing the mathematics. So the question is,
okay. Yeah.
the question
Right.
is, can we apply math types in Wolfram?
Well, I mean, we have a whole system. Let me show you. I can probably just show you. Let's see. I have to say I don't use this all that often myself, but let me show you. Hold on here. Where did I have it? There we go. Okay. So I mean, you can go ahead and type, x squared over x plus 1, this kind of thing. You can also, there is also a palette, which I admit that I don't use very often. Let's see. Basic Math Assistant. There we go. Okay. Let's see. Let me make it bigger here. So this allows you to, let's see, I'm sure I can select that and I can make it a square root and so on. There's an advanced one. Okay, you can do all kinds of things here. You can type in integrals and all that sort of thing. So that's the way that you do this in our notebook system. Yeah, it's rather straightforward. Actually, a new feature you can, if you happen to know. Yeah, I mean, it's straightforward. This is straightforward. This is how a large fraction of the world's research mathematicians, do their math in Wolfram language, specifically in our Mathematica product. I bet they don't use this palette very often because I think they know how to type all these things just on a keyboard. But for educational purposes, it's very useful sometimes to be able to show this notation. And yes, you can absolutely use this kind of palette to do that.
So we thank you so much for all the question and answers. So excuse me, Professor, so would you mind answer the main question later? Because we still spend a little bit more time to answer all the questions, but we're still not able to answer all. So would you mind to answer it later then?
I don't know what later means, but I have to go off and do other things. But I'm delighted to, if I can't answer these questions, David Varnanen, who works with us, I think is at this conference, and maybe he can answer some of these that I don't get to here. Or I could probably answer a few in the chat. Is that the right way to do it, or what's?
Professor, so we will put the links in the chat box about the forums, and then the participants can put their question on it, so that if you are available or free anytime, you can answer in the links of the forum. So that's what we mean. You can answer later. Yeah. So thank you so much. And we thank you so much for spending your times, joining us today and sharing such a very interesting and useful topics for all the participants around the world. So we thank you so much, and we hope to see you next time. Yes. So thank you. Goodbye. See you later.